Alright, practice problem 9.1 just says use the VSEPR model to predict the molecular geometry of O3. So if we have O3, we can calculate up our number of valence electrons, which is 3 oxygens. So we have 6 times 3. Each oxygen has 6 valence electrons for a total of 18 electrons. Okay. Well, we know O3 means that we have 3 oxygens bound to one another. Okay. So right off the bat, we can subtract out 4 electrons, leaving us with 14 electrons. Okay, and if we go ahead and donate these electrons, or put these electrons around to fulfill the valence, 6 there, putting 6 here, and then it leaves us 2 more for the central oxygen. What you'll notice is that the central oxygen, okay, is only going to have a total of 2, 4, and 6 electrons around it. Okay, and so it still needs 2 more, and so we can remove 2 of the electrons from one of these. Whoops. To basically give us oxygen double bound to oxygen with 4 electrons over there. Okay, and so now each of these should have a total of 8 electrons around them. Okay, so the first question then, since we know this is going to be in resonance, right? So we have oxygen double bound to oxygen bonded to oxygen. Okay, so we can draw the resonance structures, but then we need to figure out how many electron domains are around that central atom, okay? Because we're trying to predict the molecular geometry. And so we know that when we're talking about electron domains, basically we're talking about any non-bonding pair, a single bond or a multiple bond, is each going to have a single electron domain. Okay, and so if we look at this, we see that this oxygen has 1, 2, 3. Okay, so it has 3 electron domains. And so then if we use our chart, our table, we see that the electron geometry is trigonal planar. Okay, and since we know that we have 1 lone pair and we have 2 bondings for our electron domains, then we know the molecular geometry must be bent.